Hello everyone, my name is Moinak Singh. I am presenting our CVPR paper Unknown Prompt, the only Lacuna, Unveiling Clip's Potential for Open Domain Generalization. In this work, we have introduced Open Domain Generalization task using Vision Language Model Clip. Open Domain Generalization is a setup for multi-source single target domain generalization where the completely unlabeled novel unknown classes are not present during the training time. Previously, CNN models have faced lots of difficulty to recognize unknown classes in distribution shifts as they are not present in training. However, zero-shot learning, few-shot learning methods and generalization models are able to detect them, but the classes are not still completely unlabeled. Clip has also introduced zero-shot transfer and text modality, but it still requires class names during inference. To mitigate this problem, we generate pseudo-open samples denoted as unknown samples using a pretend stable diffusion model for training purpose. In addition, prompt learning becomes very popular in generalization of vision language models. So we also introduce a novel domain-agnostic prompt learning strategy by using visual style features in the text modality. And lastly, we create learnable latent space by maximizing the similarities between the clip's textual and visual features to enhance the visual semantics. In the first stage of pseudo-open sample generation process, we have taken a pretend stable diffusion with positive prompts taken as any source domain of an unknown class or object which is open to anything. We use known classes as negative prompts as a restriction what we don't want to generate. In the second stage, we use both of the known and unknown samples and introduce a domain-agnostic prompt learning method by eliminating the features of only domain-specific prompts from domain-specific class prompts. We take the domain information from the style information of the visual modality. Now, we use the domain-agnostic text features as a learnable latent noise and add it to the class samples to enhance the visual semantics. And lastly, we calculate the similarity between the visual features and domain-specific class features. So during training and inference, we consider total C plus 1 classes, where C are the known classes and 1 is the single unknown class. During inference, all of the novel classes will be considered as a single unknown class, as we consider the novel classes are completely unlabeled. And we also introduce a cross-domain semantic consistency loss to minimize the cosine distance between the text features of a common class, but with different source domains. We did our experiments in different datasets like PAX, VLCS, Office Home, DDSDG, and Min Domain Net. Additionally, we use a multi-dataset which includes Office 31, STL10, and VISDA 2017 as source domains and 4 domains of DomainNet dataset as target domains. We experiment our model with ODG baselines along with different VLMs and found out VLMs like Co-op, CoCoOp, Maple are not able to perform in ODG setup, but they show super performance after addition of the stable diffusion generation process like ours. We ablate our model with only positive prompts and including positive and negative prompts. We see positive prompt has the possibility of generating of known classes and reduces the influence of unknown class that becomes problematic to segregate the unknown samples from knowns. We also ablate our model without latent space and semantic loss, without semantic loss and latent space from manual prompts without prompt learning and hours. Previously, baselines have used different pseudo-category sample generation process like QMix, OpenGAN, etc. We have shown that a pretend stable diffusion has greater potential of generating open objects with good quality. We also have shown the importance of LCM loss, that is semantic consistency loss, as for that the cosine distance between the visual and text features of categories become higher. We also ablate our model with different splits of the novel and unknown novel classes, known and novel classes. In conclusion, we try to keep the inference as real world applications where the unknown samples will be gathered in a single cluster, not to misclassify in the known classes with distribution shifts. And we are successful to do that only using an unknown prompt with vision language duality. Thank you.